Hi, I'm Bob. Welcome back to 5 Minute Econometrics, a series aimed at introducing basic econometric concepts, estimation methods, and identification strategies. In the OLS regression results window, we can find the OLS estimates, their standard errors, the t-statistics, the p-values, and the 95% confidence intervals. We have already discussed the t-statistics and p-values in previous topics. Today, we will explore the confidence intervals. A confidence interval is a range of values for a population parameter. It is determined by the OLS estimate, its standard error, the model's degrees of freedom, and the confidence level we choose. We can use it for hypothesis testing. If the hypothesized value is not inside the confidence interval, then the null hypothesis is rejected. A 95% confidence interval is constructed by its lower bound and its upper bound. The lower bound equals the OLS estimate minus C times the estimate's standard error, while the upper bound equals the OLS estimate plus C times the standard error, where C is the 97.5th percentile in a t-distribution with n-k-1 degrees of freedom. C is also the critical value for the 5% significance level in a two-tailed t-test. For example, in the workers' wages model, the 95% confidence interval for the variable schooling is from 0.086 to 0.103. The lower bound is computed as the OLS estimate 0.094 minus the 5% critical value in a two-tailed t-test with infinite degrees of freedom, 1.96, times the standard error, 0.004. The manual calculation is the same as that in the result window. The null hypothesis is that beta equals 0. 0 is not in the 95% confidence interval, which means we can reject the null hypothesis that education has no effect on wages at the 5% significance level. We realize that we can reject many hypothesized values as long as they are not inside the confidence interval. We cannot reject many hypothesized values either, as long as they are inside the confidence interval. For instance, we fail to reject the null hypothesis that beta equals 0.1 because 0.1 is in the confidence interval. In other words, we cannot reject the null hypothesis at the 5% significance level that each additional year of education increases wages by about 10%, after considering the effects of other variables in the model. Confidence intervals are also known as the interval estimates because they provide a range of likely values for the population parameter and not just a point estimate. For example, the OLS estimate for schooling is 0.094. It is a point estimate. The 95% interval estimate is between 0.086 and 0.103. It means the true value of the parameter beta falls in this interval 95% of the time. Today we discussed the relationship between the confidence intervals and the hypothesis testing. From the OLS regression results window, we can read the 95% confidence intervals and determine the significance of the parameters by examining whether 0 is included or excluded from the intervals. Thank you so much for watching this video. See you soon. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.